Before we get started, we're just going to get a demo rolling over here. Clock is running. Great. We'll come back to that in around 9.5 minutes. These are the founders of Google in the garage that they started their company. And to me, this photo is really inspiring. These two people were able to go from an idea to world-changing product and company that reaches billions of people in a relatively short period of time. That's incredible, and that's something fundamentally new in history. It's only been possible in the last few decades and only in the world of software. In software, you're able to go from an idea, try it out, improve it, and scale it up incredibly quickly. And that's really powerful. In contrast, we live in the hardware world, and this is the first factory that Formlabs built our first product, the Form 1, in. It's a contract manufacturer in San Diego, and it's quite a bit more than a garage. At the same time, this was the bare minimum to ship even a sort of a minimum viable product. And we've actually had to go much further than that in terms of supply chain and factories to get to where we are today. And we're still at the fraction of the scale and impact that some of these big software companies have reached. So this, I'll be honest, makes me a little bit jealous. And I wish we could do what can be done in software. But more than making me jealous, I think there's a big opportunity here. The biggest problems in the world are physical problems. Poverty, healthcare, sustainable energy, all these huge problems that we want to solve, they're in the physical world. They're going to need physical solutions. And software and AI are changing things, and that's great. But we need to make an impact in the real world. So software, if we had the ability that software has to iterate quickly and innovate and scale up, that would be incredibly powerful. Now, why is it so different in these two worlds? I think it comes down to tools. This is an injection molding tool, and it's representative of a lot of tools in manufacturing. It's a big chunk of steel. It costs many thousands of dollars to make one. It takes many weeks. And you have to do all that before you even get one part out of it. Then if you want to change that part even a little bit, you've got to repeat that cycle, spend a lot of money, take a lot of time. And so that inspires a conservatism to the world of making things. There's this phrase, measure twice and cut once. And that makes a lot of sense. If you're cutting a big chunk of steel like this, you want to get that right the first time. And so the whole culture of making the physical world is built around preparation, refining your idea, and all that before you make even a single thing. And that's a problem. I think this prevents us from making bold choices and moving quickly. In contrast, in software, the tools are very different. They're fast, reliable, low cost. You don't think about trying a line of code. You just run it. You don't think about changing it and iterating it. And you think about that measure twice, cut once. In software, you do almost the exact opposite. You will often write two versions of something, ship them both, and then see how they perform with customers. It's called A/B testing. It's almost a complete inverse of measure twice and cut once. So you might say, okay, well, software, hardware, they're different worlds. This makes sense. But I don't think they're so different. In both software and hardware product development, you're trying to do roughly the same thing. You're looking out into the world, finding a problem that needs solving, designing a solution, engineering it, bringing technology to bear, refining that, and shipping it. So how come we end up with this completely different paradigm? I don't think it has to be that case. I think it's because of these tools. And if we had tools that let us iterate quickly and were reliable and produced the output that we expected, and we didn't have to worry about trying things, we could see some of these benefits. So Formlabs is a 3D printer company. 3D printers are one approach to solving this. But 3D printers have been around for a while, and it doesn't seem like this problem is solved yet. So for most of their history, 3D printers either looked like this, big expensive tool that is inaccessible, which kind of like traditional manufacturing, or like this, low cost and unreliable and not good enough for professional use. So we set out to build something different, and that's why we started the company, to build the tools that make it possible for anyone to bring their ideas to life. And we've been working on this since the beginning. We started with the idea of bringing powerful stereolithography, 3D printing to a much wider audience, making it more accessible. Stereolithography makes high resolution, beautiful, detailed parts. Then on top of that, we added a range of materials, high impact strength, biocompatible end-use materials, tools you can even make an injection molding tool out of, silicones, and even high performance technical ceramics. So making our tools much more versatile and powerful through this range of materials. And then we brought it all together with an end-to-end system where you bring your 3D model, and we have the software, hardware, post-processing, materials, everything you need to take that 3D model and turn it into a great part. The result and the feedback from the world has been awesome to see. We've shipped more than 130,000 3D printers. That's more professional 3D printers. Thank you. That's more professional 3D printers than any other company in the world. But it's not about the printers we ship, it's about what they do for people, and what they do is make parts. They've produced 300 million parts. And the reviews along the way have been great. People recognizing the work that we do to make an easy-to-use, reliable, high-quality system and make it affordable. So we've been doing this over several generations, starting with the Form 1 in 2012. And it's an iterative process. There's a lot of work to do to make these great tools. So we got to the Form 2 and Form 3, we got to continue improving it. But we're still just scratching the surface of making the hardware world more like the software world. There's a long way to go. And we need better tools to do it. So I'm excited to say that we've gone back to the drawing board to build a new generation of our stereolithography tool, to build a tool that works as fast as you can think. And today, I'm going to introduce to you the Form 4. It's beautiful, isn't it? But that's not why we built it. This is a machine built for function and performance. So let's go see it print. So when I got on stage and started the demo about 9 minutes ago, these printers started printing. The first job here is done. This is a dental arch build with 11 dental arches and completed in about 9 minutes. Looks good, so I'll just hit the thumbs up on the screen. So over the course of the rest of the about 45 minutes that will be on stage here, the printers are going to keep printing, and we're going to keep turning them over. So you'll see how much 6 printers can get done in that time. Or you could think of it as how much one printer can get done in less than an 8-hour workday. And you're going to see a lot of builds pile up here. So I'll invite Peter San Roma on stage. He led print testing on the Form 4. He's run thousands of builds already on this machine, and he'll do a great job of keeping these machines running. So it's fast. It's not overnight fast. It's while I grab a coffee fast or while I give a keynote fast. And let's look at that in numbers. For some typical builds, those dental arch builds, which our dental customers run a lot of, under 10 minutes. Most builds that people are running under 2 hours, mid-sized parts, typical parts, and even full build volumes in about 5 hours. It's 3 to 4 times faster than our previous generation. So parts being done 3 to 4 times faster is great, less waiting. But that also means you can produce 3 to 4 times more, 3 to 4 times more productive. So in the time that you might have gotten one version of something done, you can now get many. And that means you can improve your design, get to a better result faster. This is physical A/B testing. There's another way to look at the speed, though, and that's throughput. And this is something I'm really excited about. If you look at the time per part, the way you might think about things in high-volume manufacturing, lots of parts, small parts now, are in the minute range, and we have to start talking about seconds per part. Those dental arches, 49 seconds. Other small parts in a range of materials and layer thicknesses in that 1 to 2 minute range. So how do we make this possible? I want to go into some of the technology behind this. With Form 4, we introduced a new print engine called low force display. Now the print engine is what we call the core technology inside a printer. The actuators, optics, sensors, everything that comes together, interacts with the material, and shapes your part. And the print engine defines these kind of core print performance characteristics: speed, resolution, accuracy, materials range. So getting the print engine right is the core of building a great printer. And with each generation, we get to go back and build a new and better print engine. And you're always balancing some of these characteristics, but the real goal is to find a way to push them all forward. And I think we've done that with Form 4. Let's see what's inside LFD. It starts with the backlight unit, the BLU, which generates high power, collimated, uniform light, enough to deliver 16 milliwatts per square centimeter at the print plane, the highest in its category. And then that light passes through the light processing unit, the LPU, which shapes and modulates that light, forms the cross-section of your part. And then, of course, that process is repeated layer by layer to build up the part. And then on top of the LPU, we have new release texture system, which reduces the peel forces involved in printing by 40%. And this is really critical. The forces applied to a part in stereolithography, a printer like this, can limit the size of the parts you can produce, can limit speed, or limit the quality. So bringing down those forces significantly allows us to have that combination of great parts, high speed, and large parts all in one system. So let's look at an actual LPU over here. This is the LPU, and at its core is a liquid crystal display. And LCDs have been used in 3D printers before. They offer a really great combination of resolution, speed, cost. It's a good technology to build on. But so far, they haven't been good enough for a professional system. They haven't been reliable or consistent enough. So let's look at a typical LCD from another printer. This is an LCD from another 3D printer. This is actually how it comes to the user, and this is meant to be a user replaceable part. It's a bare LCD with a flex cable coming off of it, fragile and difficult to handle. If we come back to the LPU, it comes in a robust aluminum frame. It's got electrical connectors if you need to replace it. It's much more than just an LCD. It integrates heating, temperature sensing, which gives you temperature control of the resin. That's important for consistent and reliable printing. And then it's engineered for high reliability, engineered for more than 1 million layers in our typical general purpose resins. So this is now a professional grade LCD system. I want to talk more about reliability. Reliability is the dirty secret in 3D printing. 3D printers are not as reliable as people like. There's hardware failures, there's print failures, and that's why we've made it a priority since the beginning of the company to improve on this. And when we ask our customers today why they choose Formlabs, reliability is always in the top 3 reasons. So we've made progress, but it's not good enough. We need to go further. I want to tell you a little bit about how we work on reliability. We track something we call print success rate. So when you saw me press the thumbs up and thumbs down on the screen of the printer, that's data that we use to track, is the print successful? And this is the ultimate measure that matters for our customers. Did you get out what you expected? We started tracking this with Form 2, and we use that to inform a lot of design decisions and try to drive this metric up. And then with each generation of new printer, we get a chance to bring new, better hardware that can bring us to a new level in terms of print success. And we did that with the Form 3. But on top of new hardware, what we can do with settings and software updates that are delivered to all of our customers is drive that print success rate even higher. So over the life of Form 3, we actually halved the failure rate, and we delivered that to every single person who has a Form 3 through these settings and software updates. So now with Form 4, we get another chance to bring a new hardware platform that takes us to a new level. And I'm excited to say that from day 1, Form 4 is matching the print success rate of Form 3, and that's just the beginning. We're starting another cycle of this continuous improvement through settings and software updates, and again, that's going to be delivered to every single person who has a Form 4. So today we're announcing Form 4, but there's a few other new pieces to the ecosystem, and I want to dive into another one I'm really excited about. And that's our next-gen materials. We have built out this range of high-performance specialty materials for different functions. But today, we're announcing new general-purpose materials. So we went back to our most popular, highest volume materials and improved them. So they are harder, better, faster, and stronger. Our GPV5 materials improve on all of the main mechanical properties versus our V4 materials. Higher strength, higher stiffness, higher elongation at break, and higher impact strength. This means tougher, better parts. In fact, we improved so much that it matches or beats our premium Gray Pro resin on all these major metrics. But harder, better, faster, and stronger is not enough. So we also made it cheaper. GPV5 is starting at $99 per liter. That's 1/3 less than our V4 materials, or half of our Gray Pro material. And this is the 1 liter pricing. There's lower pricing available in volume. So the new lower cost materials are a piece of what contributes to overall Form 4 having a 40% lower cost per part. We've got the new materials, we've got new lower cost and longer lifetime resin tanks, and then of course we have that 3 to 4 times print speed increase, which significantly reduces the amortized cost of the hardware. So bringing it all together, Form 4 is fast, reliable, and affordable. And all that is built on this stereolithography platform that we've been building over the years. Great high resolution, high detail parts, amazing materials, and an easy to use ecosystem. Now, how much does it cost? We're introducing Form 4 at $4,499. And really excited to say that we're already in high volume production. And that means that if you order today, deliveries start in 2 weeks on May 1. So there's a lot more to cover, a lot more to dive into here. And in a few minutes, David Lakatosh, our Chief Product Officer, will come on stage, walk you through some more of the details and a workflow of using a Form 4. But I want to leave you with one more thought about where this is all going longer term. So people often ask me, does Formlabs focus on prototyping or production? And I've always struggled with that question. When I look at what we work on internally, we're making the printers faster, more reliable, lower cost, better materials. Those things are great whether you're making 1 or 1 million of something. And we've got customers that span that range, making 1 to millions of something. But I understand where the question comes from. Typically in manufacturing, there's a huge divide between prototyping and production. You'll use different tools, different suppliers. It often happens on different continents. So there's a big leap when you're going from prototype to production. But maybe it doesn't have to be that way. If we go back to the software world, we have these fast, reliable, low-cost tools. But I realize there's one more important characteristic that makes them the way they are, and that's scalable. A software engineer can write a line of code, and in the morning run it on their laptop, and in the afternoon it's running on hundreds of servers across the world, deployed to millions or billions of users. And it's doing that with one tool chain. That's an incredible capability, and nothing like what we have in hardware. And I think that is critical to achieving this goal of making hardware products more like software products. So this is a holy grail in 3D printing. In our case, injection molding is the benchmark. If you want to make low-cost, high-volume plastic parts, it's a great established process. And we're not all the way at this holy grail yet of matching injection molding. There's still more work to do on materials and reliability and driving down cost per part. But with Form 4, we made a really big step. And I'm excited to say that for many parts, 3D printing is now faster than injection molding. I'm going to leave you with this. I'm going to leave you with this video.
Wasn't this amazing? I am personally really blown away by this video. We have been innovating for the last 10 years, improving desktop SLA 3D printing. But to see the leaps that we've made here to match the quality and the speed of injection molding, to me, this is really mind-blowing. So we're going to have a little bit of fun here. Max introduced the vision and the long-term where we're going. I want to dive a little bit deeper into how we got to this product and how you use it. The Form 4 is the culmination of a lot of years of work and a lot of experience. We have over 130,000 printers out there, 300 million prints, and we're not just excited about this, we're learning from this continuously. 75% of our printers are constantly reporting to us, which means that we know what are the things that there are problems with, what are the things that are succeeding. We have also conducted a lot of interviews, and then we made a big investment. We spent the last 3 years, over 100 engineers' time, built 350 prototypes to come up with this product right here. And I think it's nice to talk about these things, but I think since we have a hardware product, the best way to walk you through it is really to show you how it works. So in the next 15 minutes, I'm going to get you all to be expert users of this product. I'm going to leave in 15 minutes, and you should be able to get going. This is the Form 4, and we're going to be printing actually a component on it, the Form 4 tower cap on the top. And as you can see on the image, it's a relatively large part. In fact, if you try to put it on a Form 3, it fits, but it barely fits. And you have to angle it up. And this is something that many people might know, that if you angle something up, usually it takes quite a long time. We made the Form 4 30% larger. But we also made an inside, looking at all of that data. Most parts that you're printing, they're not rectangular. They're longer on one axis. So we've elongated the build area to be longer on one axis. We have 22% larger parts that can fit on that, which is awesome. And yeah, this is the Form 4. It fits on any engineer's or product designers or healthcare professional's desk. We have a wide range of customers. We created a universal product that can really work well in a number of different applications. But it also means that we need to train a wide range of customers. So we need to make it incredibly intuitive. And the intuitive design starts with the UI itself. As you can see, there are 3 things that I need to start a print. I need a build platform, a cartridge, and the resin tank. I'm going to insert all of these and talk a little bit about how we design them. I'm going to start with the resin tank. So you can see the resin tank is designed to be stackable. This is important if you're using a lot of different types of materials. You want it to have the least amount of space that is taken up on your desk. If I pick it up, you can see that it has a flexible film on the bottom. In fact, it's a dual layer design. On the bottom of it, you have a layer that ensures that there are no punctures or scuff marks that can inhibit the printing. And on the top, it's flexible, which allows us to not have a lot of force on the parts themselves, which usually leads to print errors. This is something that a lot of other printers don't do, and because of that, you need to constantly change them. These print tanks are able to withstand more than 75,000 layers. Another thing that you might notice on the bottom is a metal frame. This is important because it keeps the film on the tank stretched and ensures high print success rate. Last thing about it is a mixer. This is something that you might have seen on our previous printers as well. It ensures homogeneous resin inside of the resin tank. And if there's any errors or debris in the tank, it detects it and pauses the print so you can make sure that you catch it. Let's insert it. I'll open up the machine, and it fits right in. Locks in with 2 latches, and then I can secure the mixer. You might have noticed that the printer prompted that I inserted something. This is really important because we keep track of all accessories and everything that is going on inside of the printer. It ensures that if you have a print, we're matching the resin tank, the cartridge, and the build platform to it. I'm going to confirm that I've inserted a mixer as well. Next up, I have the build platform. The build platform, we call it Build Platform Flex. This, you will never guess why it's called Build Platform Flex. This ensures that I can instantaneously move parts once a print is done. I'm going to insert this one as well. I'm all done inside of the machine, so I'm going to close it. Last one up is the cartridge. We have redesigned the cartridge from the bottoms up. We looked at a lot of comments from our customers. We wanted to make sure that you can start the print instantaneously. So this resin tank and the assembly inside of the machine is able to fill a completely new resin tank under 5 minutes, so you can start prints immediately. We've also designed it with sustainability in mind. You have more than 60% reduction in the plastic waste that this part produces, and it also has a smaller footprint. So if you have lots of resins in a scenario like a production scenario or a dental lab, you're able to stack a ton of them next to each other on the shelf. I'm going to insert this one as well. Great. You can see that I've inserted the build platform and the resin tank as well. We are ready to go. The print right now is in ready to print state. So if I send a new print to it, it's just going to start automatically. This is a great time to step back a little bit and talk about our materials. I am really proud of what we've done here over the last 10 years. We have created materials ranging from general purpose materials to engineering materials, various ISO 13485 biocompatible materials from dentistry to healthcare applications, and specialty materials that are really, really cool. But we don't only work on the materials. We also work on the print settings. And this is a really key part of the ecosystem. If you have just the material, but you don't control what's going on the machine itself, you might run into unintended issues, and there is a little bit of a guesswork going into what's the right print settings on it. So we have a huge team inside of Formlabs whose job is just to dial in about 300 different settings on the printer for every single material, for every single layer height. This is the reason why we can achieve those print success rates that Max showed you before. I'm a little bit in love with these materials, so I have to tell you, I couldn't just talk about them. I needed to show you a couple fun things here. So I'm going to put on some safety glasses. Don't worry, this is pretty safe. And I wanted to show you 3 materials that are really cool, and I can demonstrate a little bit their performance. First up, we have Tough 2000. I printed this hammer in about an hour. And we designed this with durability in mind and impact strength. So I should be able to hammer in this nail. Let's see. I didn't hold back. All right. So it didn't chip. It's still, in fact, I use it for every single demo. Great. Next up, this is going to look a little bit more dangerous, but I wanted to show you our flame retardant material because it's a little bit crazy that you can have a plastic that exhibits these properties. So the flame retardant material is a UL94V0 material, which means that you can only pass this certification if you light it on fire, and within 2 seconds it needs to be extinguished. So let's see if we can do it. All right. Opa. Okay. Let's see. So it should extinguish very quickly, so pay close attention. Up. And, all right. But I didn't even catch fire. All right. All right. All right. Next up, I want to tell you a little bit about how to start a print. So we're going to switch over here to Preform. And once it's up on the screen, I can walk you through a full print. So first of all, we're going to choose a printer. My printer is called Vibrant Crane. This is a really cool notation. We call all of our printers after an adjective and an animal. And once I chose it, I have a list of options for materials. Today I'm going to choose our new fast model material. Once I apply it, you can see that I have a Form 4 sized build area, and I'm going to choose the tower cap. All right. So you can do a couple really cool things here. But today I'm going to just simply orient it. Once I oriented it in a situation that I like it, I'm going to ask the printer to generate print settings. And this is going to take about 20 seconds. Support structures are really important for inverted SLA printers because you're printing upside down, so any unsupported minima would fall off the printer. While this is generating, I'm going to take a look at what's going on with the printers. Peter has been doing a great job here. We have already 6 build platforms ready to go, and 6 times about 7 parts. So we're already in the 40, 50 parts area, which is great. And this generated in the meantime. I can take a look at whether I like all the orientation and are there any parts that I don't want to support, but it looks good to me. I can take a look at how it would be printing, which is a really nice visualization. And I'm able to send it now to the printer. So once this print has been sent, it's going to automatically start the print, which is ready to go. Switching back, I'm done now. All of the accessories are in the printer. The print file has been sent. Once the print is uploaded, it's going to start. This is a common time to go back to Dashboard. This is our online product where you can track all of the prints, all of the accessories. You can take a look at if there are accessories that you're about to run out of, and you can even schedule prints ahead of time, which is a really cool feature. But you don't have to worry. We have designed the machine around reliability, and we have sensor loops inside of the machine constantly tracking what's going on inside of the printer. We have 4 sensors on the build platform. We have the mixer checking for debris, and amongst other things, we also have a new feature, a camera, that allows you to take a look at your printer anytime you wish. There's another thing that you can do with it, which I really love. You can take beautiful time-lapse videos like this. And we had endless debates about who will be interested in this, but I have a hunch that everybody will love this feature, and I cannot wait until all of you are sharing your hopefully not secret projects online with all of us. Great. So this print is going to take about 1 hour and 30 minutes or so. So I've cheated a little bit, and we are going to fast forward. We're going to fast forward to the next steps. After your print is done, you get something like this. Beautifully rendered part on the build platform Flex. I'm not going to remove it yet. I'm going to put it into the next step, which is a wash station. This is called Form Wash. Form Wash has been updated to fit the Form 4 size, and it also has a 67% larger area volume inside of the machine. That means that you need to change IPAs less frequently, which is something that a lot of our customers requested. It also has 3 times more agitation, which means that all the nooks and crannies are going to be nice and clean by the time this is done. So this is going to take about 5 to 10 minutes. So we're going to jump ahead in time one more time. And now I have a washed part ready to go. This is a great time to remove it from the build platform. So just so you can see how effortless it is, I can pretty much do it in midair. And you have the part ready to go. The next step and final step is going to be curing the part. I'm going to insert it right to the form cure. I'm going to set it up with the presets that we recommend. Curing is an optional but essential part of the experience because it locks in the final material properties and it really gives the part its kind of final form. Once this is done, last skip forward, I have a fully washed and cured, ready to go part. But this is not my final part. I still have some support structure on it. So this is an essential and really cool part of the experience. We call it light touch supports. It's an optimization between hardware, materials, and software that allows us to balance print success rate with the ease of removal. So I should be able to do this live as well. What can go wrong? So it's removed just like this. You can see that there are still a few tiny bits there, but basically it's ready to go. I can either finish it, paint it, or just use it as is. So this is it. I promised you I'm going to be off in 15 minutes. I think I have about 2 left, so I need to speed up here. We have a whole ecosystem that takes care of you here. We have the Form 4 and Form 4B for biocompatible applications that we're announcing today, the updated Form Wash and Form Cure, accessories that will make you successful, and all the cartridges and materials that you've already loved from the Formlabs ecosystem, with more coming based on all of the bells and whistles that we were able to fit onto this machine. And if you run into any issues, we have an amazing support team globally that can take care of you. So I'm very proud of this. We've worked really hard on this, but all of that really doesn't matter. The real test is customers using these machines. And I can tell you that the early release response has been overwhelming. We see people already using these machines in new ways that are, and reaching peak productivity that we have not seen before. And I'm so proud of some of the things that these customers have said that we asked them very nicely, so we can include a couple sentences from them. So I want to read a few to them, to you. So first, Mark Honchke from Microsoft says, Form 4 is our go-to choice for projects needing tight tolerances and engineering-grade materials. It produces high-performance parts with amazingly fast print times and makes it possible for our model makers to produce multiple iterations in a 24-hour period. Something similar from OXO, the Form 4 has blown us away. It throws time out of the window to where we are no longer constrained by time. I promise we didn't force feed this line to anybody. This is something that they've actually said. And I think it really underlines what Max showed earlier with the hardware A/B testing. This is how hardware A/B testing actually looks like. Finally, Bruno from Ford, Form 4 speed and material versatility enables us to create multiple prototypes and manufacturing gates every day. The printer has already changed the way we design and produce parts, helping us drive efficiency in our product development. This is amazing for me to see. We didn't just set out to build a 3D printer. We designed a tool to help bring ideas to life. And I can tell you that these reviews are not normal. They're not standard. We've been doing this for a while, and there's always a mixed bag. Some people like it, some people don't. They have observations. The connection that these customers are making with the printers really reminds me that of the Form 1 era when we started out. And I think that there is a reason why. It redefined what's possible with 3D printing, and it made people think differently about what you can do in a day or overall when you own a 3D printer. I cannot wait to see what everybody else does with these machines. So I want to sum all of this up with a quick video, and I hope everybody has a great day.
Introducing Form 4. So fast, it will change the way you work. With most prints in under 2 hours. Iterate several times a day. With a proprietary release texture, flexible film tank, and ultra-high optical power. Produce parts that always fit, rivaling injection molding with 50-micron pixels, advanced pixel smoothing, and light touch supports. Achieve an unmatched print success rate with validated print settings, precision heating, force sensing, debris detection, and remote monitoring. Tackle any problem with industry-leading materials. With an upgraded mixer and dispense system that support highly viscous and filled resins. And do it all with a workflow anyone can learn in 15 minutes. With instant material changes, comprehensive software, and automated post-processing. Enter a new era of performance, built on our next-generation low-force display print engine, featuring a high-power backlight unit, light processing unit 4, release texture, and a flexible film tank, delivering extreme speed, reliability, and print quality. Now, anyone can perfect their products, keep production running, or improve patient care. The tool you've been waiting for, Form 4.